Hello everybody, I am Zach Peterson. Welcome back to my channel. As you can see, I'm in my home office, but I wanted to do this video today because this is going to answer a persistent question that I get from new designers as well as entrepreneurs looking for design and manufacturing services. And that is, what do you need to do to take a finished design, a finished qualified design, and turn it into a package that is manufacturable? That is what we're going to look at in this video, and we're going to run over some of the common things that I see from prospective clients. Let's go ahead and jump in and get started. Now, when you're a contract designer, or you run a design firm, or you provide freelance design services, of course, you're going to have to deal with some clients who don't actually know a lot about PCB design, but they probably have a really great idea, they have a piece of hardware, and they know they need to get it manufactured. Now, one thing that sometimes happens when working with prospective clients is that they will send an incomplete file package or none of the files at all that are needed in order to get a board produced with a manufacturer. So one really common example is what you see here on screen. A lot of times when I get a file package from a prospective client that is not experienced in PCB design, they will basically just send a set of Gerbers. And so here you can see what a set of Gerber files looks like. It is essentially just a bunch of files. They could all be named with the same extension. Here you can see that these Gerber files have unique extensions for each layer in the PCB, and that's based on Altium's preferred format for naming Gerber files. Now, these Gerber files were created from the XB PCB from Colin Muthi that I reviewed as part of our ESP32 Deep Dive series. And I'm not bringing this up to, pick on Colin or anything like that, really just to show an example of sometimes what I receive from prospective clients. Another thing that I will sometimes receive from prospective clients is actually none of these fabrication files. Sometimes what they will send is just their project files from their native CAD tool. So this is also what you should not send out to a prospective manufacturer, because most manufacturers probably don't have your CAD software that you use to create your design. So they probably can't even read these files even if they wanted to. Also, manufacturers don't actually use these design files to do any of the manufacturing. They actually use these files, the Gerbers, plus another set of files that you need to create using your design software. So what are all of those different files? Well, that's what I'm going to show you in this video. So to see what files we need, let's take a look at one of the designs that I did on the Altium Academy channel. This is our Ethernet switch project. Now here you can see what the design looks like in 3D. Obviously there's a lot going on this board. Here you can see what it looks like in 2D. Here, this is one of the layers that's shown. This is the internal ground layer, but of course we can tab through all of the other layers as we like. Now, this design has a set of outputs that has been created for it, and of course that's the case because in that video on the Altium Academy channel, we actually manufactured this, we put the firmware on it, and we went through and tested it. So, of course, this board can be produced. And that set of manufacturing files is right here in this folder. Now, if you want to watch that video or you want to get access to the original files for this design, check out the links in the description and you can get access to those files from my company website. Now, inside this folder, all of these files were created specifically for manufacturing and assembly. And if I just go one level up, you can see here we have all of the standard Altium project files. If you're using another CAD software, maybe it's KiCad, maybe it's Cadence, maybe it's Siemens, you're going to have a different set of files that make up your CAD project that you would use in your PCB design software. But ultimately, you want to create this set of files. So for PCB fabrication, we have one set of files that we need, and it's not just the Gerber files. We also need the drill files. So when you design a PCB, obviously you have all of these layers, but if you have a multi-layer board, you're going to have to make connections between the different layers, and that involves placing through holes or blind and buried vias, and those need to be drilled, whether it's laser drilling or mechanical drilling. And so you can see here, we have some of those holes shown in this view of the PCB. And so to define where all of those holes get drilled, that's why we have these NC drill files. The Gerber files and the NC drill files essentially go together and are used by the manufacturer to plan out the layer etching and then the drilling process. Now, if we like, we can take a look at these Gerber files and we can get a sense of what the manufacturer sees when they open up your file package and start to review your board. So here what I'm going to do is I'm just going to import all of these Gerber files into the CAM tool. And you can see here what this looks like when we go back to the CAM view. So this is what the manufacturer sees when they open up the design, and this is what you see inside your design software. So they actually look pretty similar once I turn on all the layers and kind of look at them in one view and then the other view. The difference here is that inside your design software, you have a lot more data than is contained inside of the Gerber files. So for example, here inside the design software on the top layer, we have, for example, a component, right? And this component is defined as an object inside of this PCB file. But here inside of the Gerber view, the Gerber viewer doesn't have any information about what the components are on this design. The only thing that the manufacturer can see is that you have a bunch of pads here, and all of these pads have some copper connected to them, but they don't know if any one of these lines is, for example, a ground line or a power line or any of that information. They need additional information in order to be able to see that. So this is what your manufacturer is actually looking at when they plan out the process to produce a PCB. So what does the drill file look like? Well, if we go back to this fabrication folder, we open up the drill files folder, you can see here that we have all the drill data in a couple of different formats, and one of these is in a text format. So if we open up this text file, you can see what this data looks like. This is what numerically controlled drill data looks like, and this would basically be used to program a CNC drilling machine, which would then punch all of these different holes that you see here in this PCB. So if you're going to produce a bare PCB with no components assembled on it, you need two sets of files. One set is the Gerber files, and then the other set is the NC drill files. And that is your minimum viable manufacturing data package that you need to give to a freelance designer like myself who might help you get this produced, or directly to a manufacturer. Now you see here in this folder, we have another set of files, which is the ODB++ files. So what is contained inside these ODB++ files? Well, this is basically a smarter data format that consolidates a lot of the information in the Gerber files, the drill files, and some of the other files into a single file archive. The reason this format was developed was to reduce the number of files that get generated when a design is being prepared for PCB manufacturing. So when you're sending your design out to get reviewed by a manufacturer and ultimately put into production, you could also send out the ODB++ archive. Now, depending on where you want to produce, not all manufacturers will even accept the ODB++ archive. A lot of manufacturers built their businesses and a lot of their automation tools around Gerber files and drill files, so that's what they want you to send them. You can always check on your manufacturer's website and see what their file requirements are. Now, one of the big reasons that we only send the Gerber files and the NC drill files is for obfuscation of the design. And if that doesn't make sense, well, just think about this for a moment. Let's suppose that this design contains some sort of critical intellectual property that I don't want released into the wild. I don't want unauthorized people to know all of the details of this intellectual property. Well, all of that information is essentially absent from a set of Gerber files. Whereas if you send a manufacturer the PCB doc file, they know every single component that's contained in this design. They know all of the connections between all of the pins. They know everything that you've done to create your intellectual property, and it's going to be very easy for them to copy it or steal it. However, when you look at this CAM view with the Gerber files, it is a little bit of a question mark what all of the components are that go into this design. The only way they're going to know what the components are is if you also send in the schematics or the bill of materials. And if you're just getting bare boards fabricated, you don't actually have to send the bill of materials or the schematics to get this manufactured. So by only sending in the Gerber files, the manufacturer will see that there are different types of chips that get placed here, but they only know what they can read directly from the PCB layers. So if the manufacturer were to look through this silkscreen layer, of course they can see here that you're putting an SPI flash chip on here. They can see that there's a 1 gigabit Ethernet interface. They can see that this looks like a big connector block, but they don't know all of the exact part numbers that are going into this design. Now let's take a look at some of the other files that are in this set of outputs. Now, in addition to PCB fabrication, you might also want to get your PCB assembled with all of your components. And so for that, you need another set of files. First, you need the pick and place file. And the pick and place file essentially says where all of the different components get mounted in terms of the XY coordinates, as well as what layer they get mounted on. So here you can see an example pick and place file that is output from Altium Designer. And here, if you just kind of look through the lines, you can see what's going on in this pick and place file. Here we have a reference designator for a particular component. And then here you can see what are the XY coordinates where it gets mounted, and then you can see the layer where it's mounted. Now, of course, this reference designator correlates with another set of files or another file that we need to get our board assembled, and that is the bill of materials. So the bill of materials, if we open it up, is essentially just an Excel file that is a table that lists all of the different components that we need to order in order to fully assemble this board. So that resistor R169 is located right here on this line, and then here we can see the part number, and then we can see where we need to order that part in order to assemble this board. So just to conclude, in order to assemble a PCB, in order to get all the components and then get them mounted onto the PCB, you need another minimum set of files. One of those is the bill of material, and then you need the pick and place file. So just for basic manufacturing, that basically gives us 4 file sets. We have the Gerbers, which have the fabrication data. We have the NC drill file. We have the bill of materials, which lists all the components, and then the pick and place file, which tells you where all the components go on the PCBA. Now, the set of files that I just detailed is your minimum viable set of files that you would need to manufacture something, but there are always more requirements than what you can communicate in just this minimum viable set of files. And we can find those requirements in our drawings. Now, drawings are very important because they, of course, give you the mechanical information that you need to build the board, but they also list a set of requirements that you expect in the finished product. Now, here inside of this set of output files, I also have some PDFs. One of these is a PDF of the schematics. Now, you shouldn't ever send in your schematics to a manufacturer when you want to get a board built. I don't care if it's just bare PCBs or the entire assembly. Don't ever send out your schematic because your schematic basically contains all of your IP for this product. Now, what about the drawings? Well, let's go ahead and open up the drawing for this design and we can see what it contains. So here in this drawing, we have 4 pages. Some of these are for fabrication, and then one of these is for the assembly. So let's go up to the first page. Here on the first page, we have a drill drawing view, and then we have all of our dimensions and our tolerances for all of the holes that are going to go into this board when it gets fabricated. We have some additional requirements for this particular board that are specified on this next page. Here you can see we have some layer thickness requirements that are specified in the stack up. And then we also have an impedance table that's used to validate the calculations that are in the design, or this can be used for controlled impedance testing by the manufacturer. Now, it's also a good deal to include a set of fabrication notes in your drawing. And that's going to include things like surface plating requirements, any sort of testing or handling requirements. It's going to list things like your solder mask requirements. It's going to list whether or not you want silk screen on both sides. It's going to list whether or not you'll accept a date code or a manufacturer's serial number or anything like that printed on the silk screen. Any of those more advanced requirements that go beyond just using a standard stack up from the manufacturer, you want to include that in a set of fabrication notes. Now, there's a lot of great information out there online for creating fabrication notes, particularly for PCB fabrication. So what I've done is I have linked an article in the video description. Make sure to go and read that to learn more about fabrication notes and to see some sample fabrication notes. Now, just like we have fabrication notes, it's also a good idea to prepare some assembly notes. And you can put them directly in the drawing, and you can normally just put them here in the corner in this white space. Now, the assembly notes are going to list things like handling and packaging requirements. For example, how do you want all of the individual boards handled and packaged? It's going to list things like RoHS compliance. It's going to list whether or not you need a specific solder formulation for this design. All of those types of issues can be listed in the assembly notes. Now, when you send these drawings into your manufacturer, they're going to look at your fabrication notes, they're going to look at your assembly notes, and they're going to use that to quote the build for your project. If you want to learn more about assembly notes, again, check out the links in the video description. There are some great articles there that detail how to write assembly notes and some example assembly notes. Thanks for tuning into the channel, and thank you for watching this video. Make sure to hit the like button and the subscribe button, and if you have any comments or questions about anything I've discussed in this video, make sure to leave it in the comments section. And I can assure you, I do read the comments, and I do mean all of the comments, so I know all that stuff you weirdos are saying in there. Also, if you ask a great question, it just might end up in one of these videos. Again, thanks for watching, everybody. I'll see you next time.